I want to just go over what we've been studying for the last 4 weeks, kind of as a little review. And then I'm going to talk about the test real quick. I would really like you to have the test finished before the end of class, but based on 5 other classes, the majority of you will not finish. So you have until midnight tonight to have the test turned in to me. All right. So with no further ado, Arsh, never worry about a retake. You're going to do fine, right? Don't worry about a retake. But the answer to the question is yes, there are always retakes available on assessments. But that's not even a question you should ask, ladies and gentlemen, because by asking that, it gives you the mindset that you don't have to do as good as you possibly can, because you can always retake the test. That's psychological thinking for you. Okay, so for the last 4 weeks, and actually for the next couple of weeks, we have been talking about bath bombs. In particular, we have been talking about the phenomenon in the gas bombs of gas production. If you remember, way back when, I took a Dr. Teal's lavender bath bomb, and I dropped it in water, and all kinds of fizzing came out, and a lot of bubbles. And then I made a couple different bath bombs and put them in water, and some fizzed better than others, but they all produced a gas, or there was a fizzing, a bubbling that occurred. All right, so we proceeded to investigate this. The first thing that we did was, whether it was a little bit of prompting from me or through your own inquiry, is did the bath bomb have the bubbles trapped inside there? Was there air trapped in the bath bomb so that when I dropped it in the water and the bath bomb started to dissolve, to break apart, that the air was released and causing these bubbles? So we went ahead and we took a bath bomb and I pulverized it. I put it in a pestle mortar and I ground it up into a fine powder and I dropped it in water. And lo and behold, it fizzed. So right there, we understood that the bath bomb was making the bubbles by something that was happening in it. There was some kind of reaction going on when it touched the water that created these bubbles. It wasn't something that was trapped in the bath bomb. So moving on to the next set, we went ahead and we tried each individual ingredient of the bath bomb in water. We tried Epsom salt in water, citric acid in water, baking soda in water, yada, 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 on down the list. And we saw, while some ingredients dissolved, some ingredients separated, none of them produced bubbles. Sometime there may have been an air bubble trapped in the liquid, but nothing produced a gas. So far, so good. I mean, this kind of everybody, hopefully it's refreshing everybody's memory a little bit. So from there, we talked a little bit about the law of conservation of mass. I showed you the bath bomb in a beaker. We weighed it before and we weighed it after, and we had a loss of mass. But then I presented to you the law of conservation of mass, that matter cannot be created or destroyed, only rearranged, which basically means that whatever I start with, I have to end with. And we proved that that was a valid law when I was able to trap all the mass together in a reaction. And we saw that the mass didn't change. So that was the open versus closed system. So far, everybody good with me? Following right along? I mean, very basic stuff for you guys, I know, but I'm just wanting to cover it all, make sure that we're all understanding this. Okay.
Repeat the last sentence you said. I couldn't hear you that well.
Okay. Basically that we proved that whatever you started with, you ended with. So we conserved the mass. Basically all I say, okay. By doing that experiment, we proved that if we hold all the, we put I say we, just if I say we, guys, just understand that I'm doing the proverbial we, all of us together. We put a balloon on top of the flask. So that trapped all the matter that was in there, the gas that was being produced. Okay, so then we went on to combine ingredients to see what ingredients mixed together would produce the gas. And we found out citric acid and baking soda were the two ingredients when mixed together produce the gas. We also found out lemonade and baking soda did, but the reason for that is lemonade contains citric acid. So citric acid was our big go-to. This was what produced the gas. All right. So then we looked at flammability. We checked the gas, and we found that the gas produced would extinguish the flame. It would not allow the flame to continue burning. So we looked at a chart, and the chart had a bunch of different gases on it, but we had to do another experiment as well. And this experiment was one on density. I had a big metal tub, put a candle in it, started the experiment. The gas that escaped from the beaker went into the metal tub where the candle was burning and extinguished the candle. So we learned at this point that the gas was more dense than the air. It was heavier, it was denser, so the air or the gas being produced sank, putting out the candle. So we learned that one, the candle or the gas being produced was non-flammable, it would extinguish a flame, and it was more dense. Well, that led us to a determination of three different gases: nitrogen, argon, and carbon dioxide. All right. Nitrogen, we really didn't talk about this very much, but let's see here. Jacob, how are you doing today, sir?
I'm doing good.
That is very good to hear, Jacob. So, Jacob, without necessarily looking at the chart, I'll give you the basics. Nitrogen is 78% of the gas that it's in our atmosphere. It will extinguish a flame and is more dense than air. Is the gas that our bath bomb produced most likely nitrogen?
I'm sorry, it stopped, it lagged
All right.
for a little bit. Can you repeat the
Yes.
last 5 words?
So basically, I'm trying to figure out what is the gas that our bath bomb produced. Nitrogen is one of the gases that it might be. Nitrogen, 78% of nitrogen makes up our atmosphere. So more than 3/4 of our atmosphere is nitrogen. It is more dense than air, and it will extinguish a flame. So is there a fairly good chance that nitrogen might be the gas that our bath bomb produced?
Yes, sir.
Okay, so let me ask you this. If our atmosphere is 3/4 nitrogen, why does fire burn so well?
Because it's higher up in the atmosphere.
No, incorrect. I mean, it's all around us. We're breathing in nitrogen constantly. All right, let me go over to Shrieker real quick. He says, I know. So, Shrieker, is it nitrogen?
Probably not, because if it was nitrogen, it would have immediately extinguished any fire that you lighted. But then, you're saying that it's coming from the bath bomb mix, right? It can't be because it's in our air all the time, every second. So whenever you light a candle, it should extinguish.
Right. Okay. So nitrogen is so prevalent in our atmosphere, the chances of it being nitrogen are extremely slim. Okay. So the next gas, argon. 1% of that is in our atmosphere, or less than 1% is in our atmosphere. will extinguish a gas and also is more dense than the atmosphere. Now, Abigail, you got question marks. Explain the question marks. What are you questioning? Abigail. Abigail, now would be a good time to talk.
She's in the call.
I know she is. She might be typing, but I'd rather her talk. Because there is nitrogen or air, but if it was only nitrogen, it might put out the candle. Oxygen is still a little bit heavier, or is a little bit lighter than oxygen, so it's not putting out the fire. The nitrogen is not putting out the fire. You need to put in a work ticket to get your mic fixed, ma'am. They will take care of that immediately for you. You are required to have a working computer. So, and the tech department will fix it for free. Okay, so argon is the next gas, and I'm going to, does anybody know anything about argon? You don't need to be sorry about that, Abigail.
Isn't it like a noble gas?
It is a noble gas, and what does that mean?
It doesn't react with any other element. It's just an element that stays there.
Not the right word. Not that it doesn't react. It does not combine with any other element.
Combine.
Noble gases, you will always find a noble gas by itself. It'll never join with another element to make a compound. So by process of elimination, we can eliminate argon because we know that a chemical reaction is occurring and a gas is being released. Argon can't be joined with anything else. So that leaves, by a process of elimination, carbon dioxide. And carbon dioxide is the gas that is being produced in the bath bomb. Now, so what we're going to do today is, in just a second, I am going to post a test. There are 4 questions on the test. The test deals with elephant toothpaste. Now, some of you may be familiar with elephant toothpaste. What it is a reaction between hydrogen peroxide and potassium iodide. Okay, so what you're going to do is you are going to watch the 2 videos. The first video shows you the reaction with soap in it. And some of you may have seen this before. The soap, the foam comes out of the flask, and they don't do, it's not a big one. It just comes out a little bit. The first video is only about 1.5 minutes long. The second video, they do the reaction, but without soap. So you can actually see the reaction as it's truly occurring between the hydrogen peroxide and the potassium iodide. So you're going to look at the test, and they're going to give you some information like potassium iodide and soap, no bubbles. Hydrogen peroxide and soap, no bubbles. Potassium iodide and hydrogen peroxide, lots of bubbles. Then it tells you to watch the second video. So you can watch the second video again. It's the longer of the 2. One's 1.5 minutes, one's like just over 2 minutes. And I want you, for the first question, to list all observations you see on the second video. I'm going to be looking for very specific observations from you, so I would list all observations that you see. Does that make sense?
Yes, Mr. Julian.
Okay. So, and then the second question that you come up to, it's going to show you a screen clip from the second video, and it shows you the mass before and after the reaction, and there's a difference in the mass. And it tells you, after combining these two ingredients, what could have caused the mass of the system to change. So you are going to look at the video, and you are going to tell me why there is a mass loss based on the evidence. And you're going to keep seeing this thing over and over again. Your key model ideas. Your key models are the pictures and the videos that you're watching. These are your key models. Then question 3, it's going to ask you, kind of like it did in our reaction statement. I asked you in the reaction statement, tell me what gases it could be. Question 3 on the test is it says, what gases could not have been produced in this process? And you will have the you'll have that chart again, the properties of some gases, to use as your list of what gases might be being produced in this reaction. So I want you to list all the gases that were not most likely produced. You don't have to tell me why. If you want to, you can, but you don't have to. But you need to tell me all the gases that could not possibly be produced. And then the last question, number 4, it says a classmate is thinking it is methane that is being produced. Tell me, then it says something, either agree or disagree, and then show me or explain to me how we might be able to test whether it is or is not methane. And that is going to be based on the information you find on the chart of properties of some gases and what we've done in the labs over the last 4 weeks. So, are there any questions about what I'm expecting from you? All right, I am posting it right now. Now, I will be in the Google Classroom until 3:10. I strongly suggest you read over the test yourself, watch the videos, and if you have any questions, come back to me before 3:10, and I will answer the questions short of giving you the answers. Sound good?